Hello and welcome to Answer Everywhere. Today we are looking at the JDK, specifically JDK 12 and the OpenJDK version. That's the openest, sourcest version that I know of. This is, I assume, going to be large and gigantic. And I'm going to spend only about an hour on it. A lot of these repos, really almost any repo, an hour is not going to give you the whole thing. And since the theme of this show is that we're always jumping into code bases that we haven't seen before, there's going to be some time kind of getting up to speed. And for that reason, we're not going to see all of the JDK. And I'm certainly by no means a JDK expert. I have used Java before, but older versions of Java, and I haven't used it in a few years. So we'll see what we see. And then if folks want to see more of it, we can do a second pass in the future at some point. So let's take a look at the code. I just recorded the Visual Studio Code code reading video, and I figured I would poke around some more in VS Code. That's a break from our usual way of using Emacs and GitHub, but we'll try this. Okay, so Java has this really long file name thing, but it seems like it's fine. So in source we have demo, hotspot, Java base, Java compiler share classes, Java data transfer. I'm not really sure what that is. Something about data transfer, maybe web stuff. I don't think that's web stuff though. Java desktop. That might be things like Swing or FX. Instrument. That might be instrumentation, logging, management. This might be possibly JVM management, naming. Net HTTP is obviously going to be HTTP and networking stuff. Prefs as preferences, I assume. RMI. That I don't know. Scripting. SE is maybe security. Then we have like SASL, I think, is a single sign-on thing. JGSS, I'm not sure. Smart Cardio, I have no idea what that is. SQL is got to be some sort of SQL support. XML, accessibility, attach. I don't know if this is about attaching to the JVM or something else. We've gone from Java to JDK, but now we see things like attached characters, compiler, crypto stuff. I think crypto key is specifically maybe PKCS11. In edit pad, I guess this is maybe support for like a code editor type thing. A minimal swing editor as a fallback when the user does not specify an external editor. Okay, so some Swing is a Java UI kit, I guess, based maybe on AWT. And that's how this is some editor, like code editor, if you want to have an editing surface in your app. And then an HTTP server, some internal.ed, some JVM stats, and what else? Internal VM, CI. I'm not sure. JVM CI. It's not entirely clear to me yet, but we can maybe look that up. And services. And then Jart tool, JavaDoc, JCommand, JConsole, JDApps, JDI, etc. On and on and on. So it is huge. It's gigantic. And we have to figure out what we want to see in about an hour that will make us feel happy and peaceful inside. I guess we want to see the most Java-y things. That might be like the hotspot stuff. It might be some of the Java internals. that people may not think so much of or may take for granted. Let's do a search for Java. What was it? Java.rmi. Remote method identification. So like maybe an RPC type thing. I don't know if it's still used. And then let's look up JGSS. Let me edit this YouTube title. All right, so JGSS, blah, 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 security enhancement list. General social surveys. That's not it. Let's try GSS security. What? We have the Garibaldi Secondary School, the Gifted Students School in Iraq, the GSS Institute of Technology, the Genome Survey Sequence, Good Johnson Suggestibility Scale. That actually seems kind of fun. Generic Security Services Application Program Interface. That's got a lot of words and it has security in the title, so this must be the Java thing. An Application Programming Interface, or API, for access to security services. What is a security service? It does not, by itself, does not provide any security. Instead, security service vendors provide GSS API implementations, usually in the form of libraries. Acquire cred obtains the user's identity proof, often a secret cryptographic key. A relationship to Kerberos. A dominant GSS API implementation in use is Kerberos. Do I believe that? It sounds like, I feel like Kerberos probably came first, right? When did Kerberos come out? History and development. 1989. The first public version, version 4, is from 1989. So where is this GSS stuff from? In use as of 2005. Okay. I think they're trying to ride on Kerberos' coattails rather than the reverse. But let's look at the Good Johnson Suggestibility Scale, a psychological test that measures the suggestibility of a subject by an Iceland psychologist. All right. Let's see if we can find it online. This has nothing at all to do with Java. Well, whatever. All right, so that's some security thing. I think SASL is single sign-on, right? Like XML-based single sign-on. Simple authentication and security layer. So maybe it's more general than single sign-on. Is it XML based? Maybe not. There's also the SASL programming language, which is different. So what am I thinking of if it's not Sassel? SAML. I'm thinking of SAML. Okay. So Sassel is something else. I don't really know what Sassel is, but it's some enterprisey security thing. What is smart cardio? I have no idea. For smart cards. Okay. I get it. Cardio begins with card. And I guess they want it to make it seem like using smart cards is healthy. Okay. So all of that stuff is fine to ignore. Hotspot agent might be interesting. And we get different ones for different thingamajigs. And if we notice here, we have C++ files. Can I open with right click? Yeah, okay. So look at a few of these from Linux, just because Linux is what I know. Yeah, I'll install C++. But don't take me away from my thing. All right. Proc service, symtab, and some tests. So that'll be a little bit of hotspot stuff. We have docs. Are the docs any good? Maybe. Let's look at the index. Can we render this? Source action. Format document. Well, that's just formatting the code. I swear there must be a way to render this as an HTML file. Let's look that up. Control-Shift-P to open the command palette. What? Seems like you have to work hard to get it done. I'm not going to do that. All right. At any rate, can I just grab this URL? How about you just let me copy path, and we'll just open it in Firefox. All right, so here's the documentation for the hotspot. We'll get back to that in a second. Let's open up some more files here. The crypto, I guess I don't really care about. Compiler, we have classes and data. Data has what? A bunch of text files. Base, Java base F sim. So these are the symbols that begin with F. Maybe. So we'll open a few of these. And then we'll also open serial ver DE properties. I'm guessing this is like Deutschland, Japan, ZH. I don't know that. Serial ver.java. What else do we have? Is this really all we have? JDK, no. Java doc formatter, that's not so exciting. I guess we'll look at serial var and module info. No, com is where I want to be. Here we go. Doc tree tools, Java C. So we have things like doc source positions, doc tree factory, doc tree path, doc tree scanner. And then here is a bunch of tree stuff. Let's look at catch tree and class tree. And we'll just look at a few of these. Binding. Okay. So that's some JDK-ish, Java compiler-ish stuff. What else do we have? Management. Again, we'll look in Linux. look at Unix operating system. I think this is just opening these all in the background, right? Or is it overwriting older files? That I don't know. Well, let's look at a few of these and then figure out if our other files still exist here. Let's look at Unix operating system.c. This is in the management folder. I don't really know what lib management is doing. Perhaps we get a code comment, but I don't see one. I don't see a header. And we're including a bunch of system stuff, including pthread. So we are presumably doing some threading stuff. And we have a struct of ticks that has used kernel, and total. I'm not sure. Maybe this is like CPU ticks or time ticks. We have a CPU load target enum that is, I guess, going to keep track of whether this is a VM only load or a global load. I'm guessing global means like all of the CPU load, and then VM only is the stuff that's only Java. We have a perf buff, like a perf buffer, that has a number of processors, the JVM ticks. So I guess ticks is presumably JVM ticks, some measure of time, CPU ticks, and a pointer to CPUs. These are counters. I'm guessing this is maybe, if we have multiple CPUs, this variable perhaps has one entry per CPU and keeps the number of ticks in an array. We have this next line thing for a file. We're just going to call fgetc until we see a new line and it's not end of file. Pretty classic. I don't know why that's not, well, it's fine. We have this get total ticks, which is presumably just going to iterate over this other data structure, maybe perf buff, and just add all the stuff. We're going to open proc stat and look for the CPUs. DEC64 expands to %LD. Okay. And so this is some separator, and we're going to scan for the CPU followed by a bunch of stuff, %LD. And we'll, I guess, load these into user ticks, nice ticks, system ticks, idle ticks, etc. And then we'll go to the next line and find the line for requested CPU faster to just iterate line feeds. So we're going to look for some specific CPU. Is that what it's saying? Did we pass in a CPU? I guess which is which CPU. And ticks is I guess going to be what? The output? On an n-way system, it is n times faster. It is n times the number of ticks that is passed in clock time. If the use ticks parameter is not null, it will be filled with the number of ticks spent on actual processes, user system, etc., since system boot. Note that this is the total number of executed ticks on all CPUs. That is blah, blah, blah. Okay, so it returns a negative value if the reading of the ticks failed. Okay, so I guess this is the out parameter. It's called pticks, whereas this thing calls it used ticks. I'm guessing that it maybe used to be called used ticks. At any rate, we're going to just fill all that stuff from proc / stat. Okay, and here's how we compute the various ticks. All right, and this is in C for what reason? I don't know. Maybe because we need to escape the JVM to read the actual underlying VM or computer or Docker container or whatever it is that the JVM is running on. We can also get the load of the CPU itself, etc. So this is Linux specific for the obvious reason that if you have a Windows system, it's not going to have like proc stat as the place where that information is kept and so on. How about we look at catch tree? I don't know. So this is part of the compiler. So it should be the part of the compiler where we're dealing with Java errors. So Java has this ability to throw errors and exceptions, I think they're called, if I remember correctly, and catch them. And this should be some part of the compiler that deals with catches. I don't know why it's called catch tree as opposed to a catch node, but maybe every catch block roots a subtree, as at least it would in the abstract syntax tree. A tree node, so that tells us, I guess, that maybe it's called catch tree because it belongs to a tree, whereas really the object is a node. A tree node for a catch block in a try statement. For example, pre must be essentially verbose or code, as we saw in the last video. So if you catch some parameter, or maybe pre says to pre-process it because we're going to apply a font here on emphasis. So catch some parameter and there's some block. And then the try, something about the try statement. I don't know what that means. At JLS 14.20. JLS looks like it might be a name, but maybe it's some Java doc directive. At any rate, it returns the catch. This thing returns the catch variable. A multi-catch variable will have a union tree as the type of the variable. Return the catch variable. So I guess if you get a union type back, but it's a tree because it's a nodey thing that goes into the compiler tree. So you have this parameter that you're catching on. The parameter is the type of exception you want to catch, I believe. And then you have a block. You can call get block, it returns the catch block, but this has no implementation. And it's an interface. That's all well and good, but someone has to implement it, right? How about go to implementations? No implementations. How about go to references? What? Let's try Emacs. That should not have failed. Am I in the bin directory? I guess I could have just searched for catchtree.java. So it does seem like we actually have references to catch tree, and we've got this visit catch thing in the model checker. We've got this Java compiler thing in tree.java. We've got a reference in try tree. And we've got this in Sun Tools, Java C trees, some API thing. Maybe this is like a network API that will serve information about Java or something. And we have a tree copier, and we're calling visit catch in many places. So let's take a look at what is it? Trees.java. Use tree with no S. Okay, so we have a reference to catch tree here. Let's find out what all of this stuff is about. So we have a public interface tree, and it has a bunch of kinds. And I guess the kind is going to be, we're just going to pass in, I don't know what this notation means, but it seems like somehow we're taking this class, and the enum is going to refer to this class int f. I don't know what int f is. Let's look up int f. Oh, interface. How to use Java enums with an interface. Each enum member can be implemented as an anonymous class that overrides things. So somehow these enum members are allowed to be interfaces. I don't know what that means, like semantically or how you use it. But each type of tree that we have gets put into this enum, and then I guess as we are parsing and doing all the compilery stuff, if we find the appropriate class, we have some enum that we like switch on, and we're able to pull out the interface based on the enum value. And we have many of them, like if statements, instance of, method, modifiers, lambda expressions, pattern cases, and so on and so forth. Try and catch, obviously. Okay, is this just all enums all the way down? There's certainly lots of them. What else do we have? Well, I guess that starts pretty early, and then we get down here. And yield seems to maybe be the last one. They have this kind thing, kind class, extends tree, interface, associated interface equals interface. Maybe this is the thing that allows us to pop this in here. So Java kind. How about Java enum kind? How about Java kind keyword? Maybe kind is not a keyword. Maybe this is just a function. Yeah, I guess this is just a function. Somehow. And returns the associated interface type that uses this kind. So if you call as interface, so if you have an enum value and you call as interface, what this does is it essentially allows you to return the interface given the enum. You could have alternatively in another language just built up a hash map, but this is, I guess, using the language to build up the hash map on your behalf in some sense by associating this data, this class data, with the enum tag. And we're returning associated interface. And somehow, I guess, this gets stored when you do that. All right, and then we have, we can get the kind, return the kind of this tree. And that's this thing. And we can call accept. Accept method used to implement the visitor pattern. The visitor pattern is used to implement operations on trees. And you get two things back. No, rather, it's, I guess, templated by two things. R&D, the result type of the operation, and the type of additional data. Visitor is the visitor to be called. Data is the value to be passed to the visitor. And return is the result returned from calling the visitor. So that's of type R. And so we've seen the visitor pattern a bunch of times, but maybe let's look at, it's used, it's used everywhere that we're doing tree-like stuff, almost always with, almost anytime you have something like a compiler, we see the visitor pattern. And basically just walk over a tree, and then the nodes somehow have the ability to have some functionality attached to them, which is like this visit interface. And so as you visit the node, you call visit on the node. The node knows how to respond to that visit statement. And that's kind of just a way of dispatching functions to trees, which might have nodes of different types. That separates the algorithm from the object structure. Because of this separation, new operations can be added to existing object structures without modifying the structures. This is an important point. If you just had some giant switch statement or dispatch method, then every time you added a new node, you would have to modify that big switch statement. Whereas with this pattern, to add a new node, you just say what it means to visit that node, and then all the rest of the code can remain exactly as it was. It follows the open-close principle in object-oriented programming and software engineering. It allows adding new virtual functions to a family of classes without modifying the classes. Instead, a visitor class is created that implements all of the appropriate specializations of the virtual function. The visitor takes the instance reference as input and implements the goal. The visitor takes the instance reference as input and implements the goal through double dispatch. Programming languages with some types and pattern matches obviate many of the benefits of the visitor pattern. So one example of that is Haskell, as the visitor class is able to both easily branch on the type of the object and generate a compiler error if a new object type is defined, which the visitor does not yet handle. Okay, so that's the visitor pattern. Double dispatch. It's a special form of multiple dispatch. And you have two things. It's basically a double switch statement. And I guess I'll leave it there. Okay. So this is where we're doing some of the compilery stuff. We've got this tree. We're going to walk over the tree and do some things. I guess let's look at class tree. A tree node for a class. Oh, I guess class tree is just going to be like when you define a class, you call class, right? Somewhere. We have modifiers, class, name, type parameters, extends, some extends clause, implements an implement clause. And so we should see some modifier tree class here, a type parameter tree maybe, an extends clause tree, and so on. So we can get modifiers, we get a modifier tree, we can get its name, we can get the type parameters as a list of type parameter trees. We can get the extends clause, which is just a tree. It doesn't have its own type. We can get the implements clause, which is a list of trees. Again, doesn't have its own implement clause type. And I guess that's because, maybe just because the type will be known already. This should be some interface type if we're implementing something. And then get permits clause returns the subclasses permitted by this type declaration. So you can restrict, I guess, who can subclass you. Is that right? I'm not sure. Since 17. But I don't know if this has been updated. Sealed classes. So since 17, we have sealed classes. I think that sealed classes is the name for you can't extend it anymore. So permits circle, square, rectangle, shape. So shape is a sealed class. We can only have certain extensions, circle, square, and rectangle. That's it. If you try to make some other sort of shape, you can't. You go to Java jail. Okay, and so this is some of the tree stuff. Let's move on from here. Here's the Java, let's get rid of this file. Java Activation 8 sim. This should be, if I understand correctly, symbols. Perhaps that the compiler knows about that start with the literal number 8. No? Maybe not. This file is automatically generated. Do not edit. We have a bunch of stuff. Class name, JavaX, activation data flavor. I don't know what any of this is. It looks like we maybe have line numbers or something. 601. Flag 601. No, those can't be line numbers. There's too many 601s. And 401s, these are maybe permissions. Get content type. I don't know what these are. This is some list of symbols. Here's E. So somehow these are generated and then they're committed to source control. Why? I don't know. Let's see if we can grab this. What's it called? java.base-e.sim.text. .txt. One moment. All right. What is this? 14 simple information for, okay, so Java JDK simple information. I guess it's maybe just all the symbols from the JDK source code. A functional interface, there, target assignment for Lambda. Symbol lookup retrieves the address of a symbol in one or more libraries. So maybe this seems to be some sort of like committed symbol table. If we, I guess, look up a method, then we can walk up to its class to see where the class was defined. It doesn't, I guess this gives us the path relative to where our Java installation is. This gives us the like linking statement, I suppose, whatever V is. And somehow here, we, instead of having the L statement inside the parentheses, we have an empty parentheses and then this L statement out here. Is that because I made some change? I don't think so. So I'm not sure what that's about. And we also have like thrown types. This is maybe the thing following thrown types is the type of exception. Yeah. Okay. And then it has some like deprecated since it was deprecated. So this is some symbol table that I guess you can use to look up stuff. And presumably this is all the stuff that's built in. And we've got a copyright statement from Oracle. All right. And then we are onto some hotspot stuff. So here's the hotspot documentation. The top level GUI program using the Hotspot Serviceability Agent APIs is called HSDB, Hotspot Debugger. To debug it, run this thing. There are 3 modes. Attaching to a local process, opening a core file, attaching to a remote debug server. Okay, so this is maybe for debugging Hotspot. But let's take a look. Well, I think we're still in Hotspot, right? Hotspot agent, libproc. So this is a C file. It's looking for things like ARM and RISC. We've got some JNI. I guess JNI might be the Java native interface. Java native interface. So this is some sort of C bindings. And we've got this PS proc handle that's going to be some handle to some process that I think is a C thing. And somehow we're going to make it available to Java. We've got a pgrab function, which can take a PID, an error buffer, and a length of the error buffer. And somehow we're going to grab some like process via it or something. So process grab core, and process release, I guess, is what this is up to. You can get the number of libs, which is the number of shared objects, etc., etc. So this is processy stuff, symbol for PC, lookup symbol. And I guess, so to look up a symbol, you give it a process handle, an object name, and a symbol name. And this is the header, libproc.h. Where's libproc.c? And then we have libproc impl, h and c. So let's look at the impl. We have a bunch of frame info, like library base address, v address, some data, size, and info. And then we have lib info, which has a name, a base and end, with the start and end part of the execution, and some EH frame info. I don't know what an EH frame is as opposed to other things in a symbol table. So I think we're like looking in ELF kind of objects and pulling information from them is, I believe, what we're doing. And we can print debug stuff and so on and so forth. And here's the actual implementation. Let's see if we can find any like magic numbers or anything. Do you see anything elfish? Yeah, we have like elf E header, elf P header. Let's look up the elf format again. Elf file. EH size. E header, I guess extended hunk. Is that extended hunk? So I think E might be for extended. Something about the extended information. Okay, so this is looking in elves, and pulling out information so that we can use it in Hotspot, I suppose. And what sort of information would we want? Well, a lot of it seems to be like just checking if. Let's look at that. Let's look at it again. Opening, debugging, getting thread info, deleting thread info, adding library info. The number of threads, or rather at least information about threads, the number of threads. Core dumps. So far I don't see anything like how much RAM or whatever something is using, or how many times something has been called. But that is presumably somewhere because we're going to do like just-in-time optimizations. Here's elf macros. This should be just stuff where defining useful things. Here's dwarf. This should be debugging stuff. I guess we'll ignore it. Dwarf parser. And then this is, so I think that maybe this hotspot thing is mainly about debugging. Here's replay. Oh, that's at least the information about replay. Okay, I think that is mainly debugging stuff. I don't know what this JVM CI stuff is. Let's look it up. The compiler interface. Develop a Java-based JVM compiler interface, enabling compiler written in Java to be used by the JVM as a dynamic compiler. Goals. Allow a Java component programmed against the JVM CI to be loaded at runtime and used by the JVM's compile broker. Okay, so this is somehow you're able to send, what year is this? 2014? You're able to like send new compiling things into the JVM, I think is the idea. And then maybe, you know, the last thing we'll see is let's check if we can find out more about the hotspot stuff. We'll ignore the tags file. Ignore YAML. How do I? There we go. Or can I do this? If we look at C files, I have a feeling hotspot is going to be written in C, although I don't know. We have java.c. Let's open that. And let's also try, I think there was a hotspot folder. Can I do this? Let's just look in source hotspot. No, that's not a thing. How about JDK? Oh, that's hotspot agent again. Here we go. So we have CPU, OS, and share. We have some C group stuff. We'll open the C group header, I guess. I don't know what a decoder is. We have some globals. Maybe the global is useful. We'll look at the OS Linux header. Look at perf Linux. We care about, let's look at threads and containers. Trim cheap DCMD. VM structs. Let's look at VM structs. Weight barrier. Should we look at POSIX too? We have, yeah, I guess, why not? OS POSIX. Perf memory, sure. Safe fetch sigjump. Semaphore. Yeah, we'll open a bunch of these. A lot of these will probably like blow past pretty quickly. GC, we haven't seen any GC stuff. X arguments. I don't know what's going to be important. I don't know what the X versus Z is. Just open up all of this stuff kind of randomly. Then we have dtrace, which should be, I think, like performance-y stuff. So that's OS. Let's look at CPU. x86, because that's just what I'm most familiar with. We can generate some assembler, some bytes thing, linear scan. Lyra, I don't know what Lyra is. Lur generator. Oh, LIR, it's not Lyra, it's Lyra assembly. But we'll look at the runtime, the code stubs, the globals. Macro assembler, erratum, frame map, probably floating point unit, stack sim, defs, and code stubs. Just open all the things. Abstract interpreter, sure. And then we haven't opened up GC for x86. This should be generation 1. Shared. I don't know what Shenandoah is. We'll open just a few of these kind of at random. All right, and we will, I think, blow past most of these. I guess I'll kind of look at them with an eye toward setting up what I would, if I were to do a second pass, I would like to at least see a lot of this stuff just to know where it is, what's in it, what's the likelihood that this is of like fundamental importance to understanding the garbage collector or any of it really. How can I, here, take this? There we go. Okay, so let's glance on through. What is this? Wait a minute. Java.c. I don't know what libgilly is. Shared source of the Java command line tool. So this is Java command line. I'm going to ignore it. Hey. All right, so here's C group subsystem. This is going to be some sort of support for C groups, like if you ran in a Docker container. Shared C groups code used by C group version 1 and 2. Some stuff about per CPU shares. We have some defines. We're in a C++ header. Diag push. I don't know, diagonal push. Not sure. I'll just kind of scroll through to see things like what are the functions. Subsystem file line contents. Parses a subsystem's file looking for a matching line. All right. Why? I don't know. And what else do we have? Cached metric. So we have some metrics, C heap obj, empty internal. So we're keeping track of some heap stuff and creating metrics for it. And then here's a class for the C group subsystem. What do we have? We have things like a JLong, I'm going to guess is a C++ version of a Java long. We keep track of the memory limit, active processor count, CPU quota, shares, period, etc. Number of max number of PIDs, current PIDs, how much memory we're using, and so forth. And we have a CPU group, C group info, which is an extension of stack object, a utility class for storing info retrieved from proc C groups. Okay, so this seems to be mostly about bookkeeping with respect to when we run in a C groups environment. Where's preferences here? Can I get tabs to open properly? I don't see any obvious way. All right. Here is globals Linux.hpp. We are in hotspot OS Linux, so this should be some hotspot stuff. And specifically some globals. So you have some runtime OS flags like develop, I guess, like are we developing, some product, PD, product, etc. Not product. And I don't know what really product is doing, but we're defining some, seems like metrics. Dump share mappings in core, some boolean if true sets bit 3 of proc PID core dump filter, thus resulting in file backed shared mappings of the process to be dumped in the core file. And these are all just seem to be defining like flags or options you can set. Let me try VS Code, open tabs, and LIFO order, and FIFO order. I have to edit JSON. I'm not doing that. Here's oslinux.hpp. Okay, and we're still in hotspot. We have some class OS Linux, and we are declaring we're in C++. We're declaring C subgroup system as a friend. OS is a friend. OS container is a friend. And we have things like the initial thread stack, top and bottom, CPU to node. So this is some mapping. I guess you give it a CPU. It tells you something about a node. I don't know what a node is. Maybe it's like a JVM unit of some sort. Commit memory impl. I guess there's some commit memory function. And this is its implementation. You can set the clibc version, the libc version. You can rebuild the CPU to node map, etc., and print a bunch of stuff and release memory. Huge TLBFs, page size flag. So this something about huge pages. This is more huge page stuff and some pthread stuff. So you could see why this would all be useful to hotspot. We haven't seen yet where it's consumed. Yeah. Here's OS perf and proc number status information about the process. So we're just basically reading stuff from the proc system. I mean, I guess there's not anything too excited, like just getting CPU load, reading data, getting the number of JVM ticks. We're still, I think, at this point, like recording metrics and doing things with metrics. We're not necessarily making decisions about how to use those metrics to find a good experience. OS thread Linux, we can set thread type, get thread type, caller sigmask, thread identifier. This seems to again be mostly like metadata type stuff. Set expanding stack, clear expanding stack. All right. OS container Linux. This should be container stuff. I think I'm going to ignore it. Let's look at trim Jeep DCMD. Trim CH heap. Oh, trim C heap. DC, I don't know. MD, I don't know. Trim clib C heap DC MD. Sounds like a poem. We're going to return the string system trim native heap. And we've got this description, attempts to free up memory by trimming the C heap. Is this a system call? This looks like a Java method. Oracle Help Center. Attempts to free up. Okay, so this is defining some function, I guess you can call from Java. What is DCMD? I don't know. D command? I don't know what the D stands for. I'm going to guess this is a command that can run somehow from the command line. And we've got this execute function, and we're passing a DCMD source and traps. So I'm not sure what that's up to, but here's the implementation. It seems like this is some way maybe for Java to call into C++. And when we call execute, we're going to take the DCMD source. And if we can trim the native heap, then we try to call os trim native heap on the source. I'm curious what happens with this variable. Where does it go? I don't know. Seems to go nowhere. But we essentially just try to call this function, which is probably some C++ function. And if we do, we output some stuff. And afterwards, we like check to make sure everything's working. So to Pratik is saying, JVM is expected to run on any machine, and it's crazy how much code they must have to make it work on every OS. It additionally also provides interfaces from the language to the underlying OS. Yeah, it is pretty crazy. But you know what? They've had it forever. I think Sun had a really interesting idea that everything would run, that you would write the code once and it would run everywhere. And it seems like, you know, older machines struggled more with running a JVM in addition to running the JVM code. But nowadays, I think nobody really bats an eye at the overhead, despite Java. A lot of people considering Java to be a kind of older fuddy-duddy language. So here's VM structs. I don't know what this is. Some structures, I guess. Some C++ structures for running in virtual machines, perhaps. Types OS, constants. I don't know what this is. Do we get a C implementation? I'm not sure. I'm going to just plow along. Here's some weight barrier for Linux. This should be some synchronization object. It's a heap, C heap object of type MT internal. It's a futex and is volatile, non-copyable Linux weight barrier. So this is somehow, and you can arm, disarm, and wait on it. So I think this is probably here to give Java access, I guess, as kind of like Pratik was saying, to give the Java world access to the underlying futex stuff of the that's running on Linux in this case. And here's os POSIX.hpp. So this should, I guess, run on any POSIX system. Note, the POSIX API aims to capture functionality available on all POSIX compliant platforms. But in practice, the implementations may depend on non-POSIX functionality. For example, the use of lseek6 and ftruncate64. Okay. This use of non-POSIX APIs is made possible by compiling, linking in a mode that is not restricted to being fully POSIX compliant, such as by declaring --GNU source. Okay. We've got this restartable thing, and we give it a command and a result, and we try to set the result to the command, and while there's an error or an e-enter, I guess we keep trying with no back off. But we've got things that we've seen before, like default stack size, some pthread stuff, real path, a safe implementation of real path, which will not cause a buffer overflow if the resolved path is longer than path max. Okay, so this is finding the real path of some file. I guess real in the sense of like, you know, you might have a path to the file that's a symlink, and then maybe it's trying to find the underlying non-symlinked version. Don't save my changes. Here's perf memory POSIX. I mean, I guess this is mainly reading memory and reading performance information, perhaps, as opposed to doing something with it. We can create standard memory, create the perf data memory region in standard memory, save memory to file, get user temp directory. Yeah. Okay. I'm going to assume this is all kind of like observing performance. Save fetch sig jump. This is something about sig jumps. I'm not really sure what's going on. I'm just trying to, I think, sprint to the end at this point. So here's signals POSIX. This should be stuff like POSIX signals like sig abort, sig int. You can install a signal action handler with the sig action and the old action and the signal and some handler. an SA sig action T, I guess, is some probably a C++ function, right? Go to definition. Yeah. It's just some C++ functions. So you can install these signal handlers, and I guess they're essentially C++ functions, and then I don't know. I don't know if presumably you can also have Java versions. Here's C1 frame map. This is starting to look more like assembly-ish. Are we in the assembly part? I think we're closer to it. On I486, the frame looks like as follows. Size of arguments, not ref args, 2 words, size locals, get arguments plus num args, size monitors, and spilling. The FPU registers are mapped with their offset from TOS. Therefore, the status of FPU stack must be updated during the code emission. So we're going to emit some code. I don't know if we're emitting code in this file or this is just we're on the road to emitting code. And what? I see a bunch of, so we see some registers now, RSI, RDI, RVX, and we are, I guess, what are we doing with them? I'm not really sure. We're just kind of like defining them. We have this long opper. We pass it a register R, and we get back an LIR opper. And we're returning LIR opper fact double CPU, passing in CPU register to R and R, and then CPU register to R and R. So we're getting like the long version from probably the short version. I'm not really sure what LIR is. Let's look up LIR. What about x86? I'm not sure. Give me about maybe about 1 minute. I'll be right back. Delete. So what if, let's try this, Java IR. How about Java intermediate representation? What's up? What's up, internet? Since we looked at uBlock origin the other day, can I just zap this whole thing? There we go. Does LIR appear here? I don't know. It may be something, some intermediate representation thing, but I'm not sure. But this is, at least we're seeing some closer down to the CPU. Here's virtual memory. I don't really know anything about virtual memory. I'm going to ignore it. Z initialize. I don't know what that is. PD. I'm also not sure what PD is. Z utils. So what's up with Z utils? We have some allocation stuff, some memory alignment stuff. We're calling memset. So this is doing memory stuff. Z arguments will ignore Z virtual memory. We'll ignore all of this stuff. Hey. Stop that. Initialize arguments. I'm not sure that's what's up with that. Is OS supported? True. So this is maybe like just kind of setting things up for the operating system. HS private.d. I don't know what's up with this. I don't think this is D source code, but we've got some provider HS private. I don't know. It's a this is dtrace stuff. Let's look at JNI. Does nothing. Maybe it does nothing. This seems to be, again, some sort of symbol table. We can look up dtrace. A comprehensive dynamic tracing framework, originally created by Sun Microsystems for troubleshooting kernel and application problems on production systems in real time. Originally developed for Solaris. Okay, command line examples. dtrace n proc exec success, and you give it some trace stuff. I assume this has to have some kernel support. Did I see Brendan Gregg? Okay. So this guy is also famous for, what's the word? Flame graphs. I don't know if they use dtrace or if they use like BPF these days. Yeah, eBPF. What? He pioneered eBPF as an observability technology. Okay, so maybe dtrace is obsoleted by eBPF. eBPF. So here's some dtrace tools from his website. I saw something about BPF. Well, that's ChatGPT. So does dtrace use eBPF, or does eBPF obsolete dtrace? There's some overlap in functionality. They're not directly related, and one does not necessarily obsolete the other. However, eBPF has gained significant traction. Some argue that eBPF provides capabilities similar to dtrace, but with greater flexibility and lower overhead. It sounds like dtrace might be on its way out, but, I'm not sure. At any rate, this is some dtrace support for Java, it seems like. Here's assembler, x86. We've got some register stuff. Float registers, register CARG1, CARG0, RDI, RSI, RDX. Symbolically name the register arguments used by the Java calling convention. We have control over the convention for Java, so we can do what we please. What pleases us is to offset the Java calling convention so that when we call a suitable JNI method, the arguments are lined up and we have to do little shuffling. A suitable JNI method is non-static and a small number of arguments, 2 fewer arguments on Windows. Okay, so we have a bunch of arguments, and we get to set up our own calling convention, it sounds like. And perhaps this file contains part of how we do that. We have some class that models the address. This is a C++ class rather than a Java class, and a scale factor. Times 8 is 3. I guess 3 being the log 2 of 8. I don't know if that's what this is recording, although it kind of seems to be. And, registry stuff. So at least this is where this stuff is. I'm not going to dig into it again. I'm trying to, I have a limited amount of time, and I'm just trying to quickly go through these and see a little bit about them. Here's the C++ implementation of the assembler. We've got some relocation stuff. What is this? Address literal. You give it an address, a target, which is an address, and a relocation type. And then based on the relocation type, we will do what? So for each of the relocation types, we have some function that knows about that relocation type and knows how to translate a target into, I guess, where the thing actually is as we take relocation into account. Use an exceedingly dangerous constructor. I guess this gives you the ability to point to anything in memory, is maybe why it's dangerous. And then there's also more dangerous constructors on here. Okay, so now we're seeing, assembly stuff. I guess let's get out of assembly land and try to look a little bit at intermediate representation, which I'm going to guess is maybe what LIR generator is about. Oh, I'm seeing so Juan Gomez is saying most observability tools now use eBPF. That seems what I've seen as well. Although certainly newer ones, but you can't always, sometimes things are still used long after they're no longer as popular. And then Pratik is saying, yeah, so if it was forked from Sun, I think that that explains why there's all of the, forked from Sun before Oracle bought it. I think we've seen Oracle copyright statements, right? So I think this must have been forked after Oracle bought it. But still, while it was GPL'd. I don't know if they've changed the licensing. And move on villain says, I was trying to read Kafka code yesterday, but where do I even start reading it? Any points? Yeah. I don't know if you were here at the beginning of when I started looking at Java. It's hard. You get better at it over time. And for some repos, first of all, they're just big. Like Kafka is a database. So that's going to be a whole lot of code. And I think the attitude you have to have is that it doesn't really matter where you jump into it. And so if you want it to not matter where you jump in, then the exploration has to be a little bit about, you're going to have to spend some time just jumping in a random place, see what you can see, and try to track down from there what might be interesting. So you're going to have to have the attitude that there's going to be some exploration before you know what you want. And so one way to do that is just to open up random files or open up the largest files or something like that. But for a database, I can tell you where I've started in the past. For the SQL databases, my initial focus was the analyzing and planning, query planning logic. You may also be interested in the file layout of Kafka files, or if there's performance impacting stuff. I don't know. Performance is a cross-cutting concern. I don't know how you would track that down, but you might look for things like I think Kafka is a distributed system. You might look for things like, do they have a Paxos implementation or a Raft implementation? Where is that logic? How does it do healing if one falls offline? There's all sorts of different tacks you could take. It sort of depends on what your interests are. And if you don't know, you just kind of want to see the Kafka code for some reason, then you just start somewhere random and see where it takes you. Hello. Hello from Korea. All right, so here we are in the LIR generator. We've got this load byte item thing. Item will be loaded into a byte register, Intel only. Load on constant. What is this? We've got exception OOP opper. Object-oriented protocol. Object-oriented programming. I don't know what OOP is, but opper, I'm going to guess is operation, some exception operation. Div in opper. Div out opper. Device in? No. Div, I don't know what div is. Rem out opper. Shift count. Sync lock, etc. I don't really know what those are doing. Those are possibly like opcodes in the intermediate language or something. We've got some frame map stuff. And we are doing what? You pass in a value type, result register 4. You give it a value type in a callee. I guess a bool indicating whether we are the callee or the caller. And you look at you switch on the tag. And if it's, for example, an object tag, then you get a frame map frame map rax OOP opper. I'm guessing maybe OOP is object. And if you give it a long tag, you get a long 0 opper. And if you give it an init tag, you get a rax O opper. Okay. I don't know what that means. We have some rlock stuff. We have this can store as constant. You give it a value in a basic type, and it should give you some Boolean. For example, if the type is T short or T character, I guess that means character type or short, then we can't store it as a constant. Otherwise, we try to get the value as a constant, and if we get a value, then we say true, otherwise false. And similarly for can inline is constant. So now that we see these value types, let's try to go to the definition of value. This should get us closer to the byte code. Value is just a double. But it can't just be a double because we're calling functions on it, aren't we? 1 second. I'll get back to the chat in just about a second. No, here's where we're calling functions on. Lur const. You've got this type check, which we call on a basic type T. And if it's just one T, we just assert that type the type function is equal to T. And I don't know what this type check thing is. Maybe that's just like what prints on the assertion. If we give it two basic types, then we assert that type equals T1 and type equals T2. What is the type function? Okay, so type returns value, underscore value get type. And where is underscore value set? I don't know. But at least now we're getting to what appears to be some type checking stuff, and we're kind of seeing where some of it associates with registers in the C++/assembly code. And we're getting things like a pointer value, a stack value, a CPU register. This is, I guess, operator kind. operand kind. I'm not sure what oper is. And then we have some bits like pointer bits, kind bits. Kind is probably like maybe the Java type, or maybe that's what type is. Size, destroy bits, etc. And I don't know what the shift stuff is. And so I think that this is maybe even closer to the bytecode. Let's see if we can find some stuff about kind bits. All right, and then I'll look at the chat here. I started reading on why OpenJDK, why it has Oracle licenses and naming. Oracle suing Google. Yes, Oracle is highly litigious. Is its reputation. They will, Sun released Java. And it was open source, and people built their own implementations of it. And then later Oracle bought it and decided that the API, I think, was copyrighted. And so they sued people like Google who had their own implementations and weren't giving Oracle money, essentially, especially around Android. It's like an open world adventure game. Start with exploring one corner. Yeah, it's exactly like that. I think that's a good way to think about it. That's a little bit how I described it when I first started doing this video series. I also described it, I think I was like comparing it to those like Survivor type shows where you dump somebody in the wilderness and they've got to like figure out, how am I going to get food and water, and like where can I find a place to sleep and stuff like that. There's an element of exploration or maybe archaeology about it. Especially if you're jumping into a big code base that you haven't seen before. But once you get a handle on things, you can, it's a different world. Okay, so I'm not going to go too deep into here. Here's some runtime stuff. I will see if runtime is compiling any sort of code. We're still with it seems like pointers and addresses down in memory land. We have a stub assembler, call RT, register. And this is somehow generating or, calling some assembly move instruction, it looks like. I don't know what RT is. Maybe call return. And what is a stub? I'm familiar with stubs from IPC and RPC mechanisms. I'm not sure if they're using a similar idea here. We've got some stack layout stuff. All the registers needed during a runtime. Okay. So this is cool. Oh, here's OOP map. Generate OOP map. I'm not sure. I'm going to just kind of go along and I'll just search for, I'll close all these, I think. Maybe C1 defs. Code stubs. We have this conversion stub. I don't know why this is being, it's like the brightness has been turned down on this section here. But we have this void conversion stub emit code thing. And you pass it in a pointer to an LIR assembler stuff. And this is going to emit code, it looks like. We're going to assert that the bytecode is equal to bytecodes F21, F2I rather. Don't know what that means. Again, we're going to call bytecode again. So bytecode seems to be consuming something. It seems to be, since we're calling it twice and getting different values, which would not happen in Haskell, it's having some side effect. And that side effect is probably consuming like an element of the bytecode. I don't know how big the words of the bytecode is. Maybe it's consuming a byte. Maybe it's consuming half a byte or whatever. So the first time we call it, we want to get underscore F2I. The second time we want to get underscore D2I. Other conversions do not require stub. Okay, so these are the conversions, I guess. Or, well, hang on. We're calling OR here. So maybe this is returning the same thing. Maybe it's not consuming something. You can ignore that. if input is single XMM, then some stuff about external address. Otherwise, we're going to push racks, ft state, maybe, whatever ftst is. This fn st wax, soft and pop. So this is doing something with racks, pushing something to it, doing some computations, and then popping off what's on racks. This is possibly somehow, I don't know. I also don't know what this dash is. Maybe this is just a space. And if this label, nan do return, we're doing this JCCB stuff. And then, oh, maybe this is less bright because of the ifdef. All right. So we're generating different kinds of code based on the LIR. I have a feeling that LIR is some sort of intermediate representation. I can't really find information about it. I guess I'll ask the AIs, which may know about it. And let's get rid of these globals. In fact, I want to kill all these files. Can I do that simultaneously? I don't know. I really don't know. Okay, let's try bytecode. Generate old bytecode. Get method ix bytecode. Bytecode.cpp. Bytecode ARH64. Case bytecode. Did I already see this? So let's go to the bytecode type. Here we go. Class bytecodes, all static. Note, replicated in SA. Here. Can I open this as a file? VM agent sun. Can I just go here? How do I, first of all, how do I undo this blame? Uh-oh. So let's just look for bytecodes.java. Here we go. No. Did that work? Go here. Go here. There we go. All right, so here's the Java version of the bytecode stuff. I don't know why that took me so long to open, but there you go. So we have a bunch of ints on the right-hand side. And then on the left-hand side, we have the names of the things. So no-op, aconst null, iconst for, iload, fload, falload, fstore, dastore, etc. New array, check cast, invoke virtual, put field, fast dput field, and a bunch of other stuff. We have some format bits, like format has C, format has J, I don't know what this formatting is. Constant pool cache index such as get field BJJ. And then what? We can do things like check if assert's enabled, assert that is defined of code, illegal code plus code. I guess if this assertion fails, then this is what's printed. It's probably what assert is doing. We can find the fetches a bytecode, hiding breakpoints as necessary. So we have this code at, we get give it a method and an int. I don't know what BCI is, but we get code, we call code or breakpoint at method BCI. If it's a breakpoint, then we call get original bytecode at BCI on the method. I don't know why we didn't call that at first, but that's a thing we can do. And then we get the result and return the result. Here's some bytecode attributes. Is defined will return something. 0 is less than or equal to code, and code is less than the number of codes, etc. So we just check that it's in the range of codes that we know about. Can trap, given a code, it will call check code and then return has all flags on BC can trap. And has all flags will presumably look at the code and maybe examine some of its bits or something. We can compute flags, doing a bunch of stuff. Okay, so here's finally some bytecode stuff. This was not originally what I was looking for when I started this repo, but I figured you might as well get to it before the end. And just like I'll scroll down and see if there's anything that really stands out to me. I don't know what this def thing is. Format string interpretation. So this is, I guess, defining some table of names and information about the bytecodes, probably for documentation, maybe for other things as well. And so that's the Java version. Here's the C++ version. You should get all of the same numbers. I hope they're all the same. If not, there's a serious problem in Java. Should not reach here for debugging. And we have the flags. I think those are probably also defined in the Java version. And similarly, we have code at, and we have this method star, and this should be the C++ version of the Java code that we had. Okay, so here's bytecodes. This is bytecodes, and what else do we know? The interpreter. That's what we didn't look at. We'll look at interpreter HTTP, and I think this will be the last thing we look at. Interpreter codelet. An interpreter codelet is a piece of interpreter code. All interpreter code is generated into little codelets, which contain extra information for debugging and printing purposes. Okay, so I guess maybe it's like a composable set of interacting codelets or something along those lines. I don't know what not product is again, but we have assembly remarks and debug strings. I guess maybe not product means like not if you're not running in production. But we can initialize and finalize codelets, I guess, get the size of what? I don't know. Size of the codelet, perhaps. Where the code begins and ends. Some debugging stuff like verify and print. We have some initialize function. Is this yeah, it's not an abstract class. Okay, and to initialize, you pass it a description and a bytecode. We can use the remarks. I don't know what the assembly remarks is. We can use the strings. And then we define a prototype interface. A codelet mark serves as an automatic creator initializer for codelets as a subset of resource mark. I don't know what that means, but that's a codelet. Okay, so now I have a few questions, and I think I'm just going to look on the internet for them. One is just about Java codelets. Another is about, what was it? Not codelets, but there's something else I found mysterious. I guess let's look at codelets and then come back to it. Oh, stubs. Ask Gemini in the JVM. Tell me, JVM implementation. Tell me about codelets and stubs. So codelets are small pieces of interpreted code. The JVM's interpreter generates bytecode into these manageable codelets during runtime. Each codelet contains the actual bytecode instructions along with some extra information. Okay, so these are, I guess, kind of like strings of bytecodes that correspond to like maybe methods or sub-methods or something. The extra information is primarily for debugging and printing purposes, helping developers understand blah, blah, blah. Stubs are like placeholders or pointers within the code. They are used when the JVM encounters references to methods that might not be readily available at that point in execution. Okay. There are two main reasons for using stubs. Lazy loading. When a class or method is not immediately needed, the JVM has a stub to represent it. The actual code is loaded only when it's called for the first time. Lazy loaded. Polymorphism. During polymorphism, where different subclasses can implement the same method, the exact method to be called might not be known until runtime. Okay, stubs act as placeholders until the specific method is resolved based on the object's type. In essence, codelets are the actual executable pieces of code, of interpreted code. Stubs point to code that might not be available yet due to lazy loading or need to be resolved dynamically. Okay, so then in JIT optimization, are the codelets the unit of optimization? Okay, so they're not the unit of optimization. Here's why. Codelets are units of interpreted bytecode. JIT compilation specifically focuses on optimizing code from bytecode to native code for faster execution. JIT optimizations typically happen at a higher level than individual codelets. This could involve methods, loops, or basic blocks, sequences of instructions. Okay. Possible units for JIT optimization: a method analyzes the method's bytecodes and applies optimizations like constant folding, loop unrolling, register allocation, and basic blocks. It might focus on optimizing smaller units called blocks. These are sequences of instructions without jumps, allowing for more targeted optimizations. Okay, so is a codelet smaller typically than a method or a block? Okay, yeah, it says it's smaller. All right. Well, I think that's enough of the JDK for now. Next time, if we want to know more, then we can look at it again. I am still in the process of trying to get through the backlog of requests that I have. After I process that, I'll open things back up to additional requests. Although there may be some sort of restrictions because typically I get a lot more requests than I can process at any given time. I do have a Google sheet of suggested requests that I'm keeping track of. At this point, I'm not promising to get to any of them, but if you want to make a suggestion, you can join the Discord channel and add it to the sheet. And then I think at some point what we'll do is we'll have some way of voting for having members of the community vote for what they want to see. And that way I can kind of balance these the requested repos with repos that I want to dig into personally. And that's all for the JDK. That's all for today. Thanks for watching.